Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is integration. What we are going to learn today is how to find the integral of a trig function. So let's begin. So after completing the very lesson today, my dear student, will be able to find the integral of a trig functions as one of the types of basic functions we have in mathematics. So we're going to learn how to find the integral of that very trig function in this very lesson. So as usual in your favorite segment of the lesson, Mercy is funny. Today I'll give you the second relationship between the Lucas and the Fibonacci sequence of numbers. Another very strong and interesting relationship between the two. That will be done after completing my lesson today, so don't go away. Now to begin the lesson, my dear student, let's have a look at some of the integral of basic trig functions. So the integral of basic trig function is as follows. Number one, if you have sin x as a trig function and you wanted to find its integral. So integral of sin x with respect to x, that integral is nothing but minus cos x plus c. Similarly, if you have a function cos x, y equals to cos x, for example, and you wanted to find its integral. So integral of cos x, it says is equals to sine x plus the constant of the integration, c. Similarly, if you want to find the integral of sec square x with respect to x, that integral is nothing but tan x plus c. Another basic trig function is cos sec square x that you wanted to find it is integral. This is nothing but minus cot x plus c. These are just some of the basic trig functions and their integral increasing. You have to commit this into your memory. That is, integral of sine is minus cos x, integral of cos x is sine x, integral of sec square x is now tan x, and the integral of cos sec square x is now minus cot x. You have to commit this into your memory. So let's just take examples how we can make use of this and find the integral of some basic functions, trig functions. So example number one, you asked to find the integral of x minus 12 sine x with respect to x. Solution to this very problem. So copying the given text, that is integral of x minus 12 sine x dx. So what you now do, remember our previous lesson. Properties of finding integral. Here I can have two terms. Here x is one term and the 12 sine x is another term. So I can apply now that property and find the integral term by term. So let me just move. So this will now be equals to integral of x dx. That is integral of the first term with respect to x minus integral of 12 sine x dx. So I continue. So what I'm going to do next is to apply another property of integration here in the second term. This is 12 times sine x, which I can factor this to 12 outside. So I will now have integral of x dx, which I just copied here. I have not done the integration yet, but here I'm going to apply that very property. So I have in 12 times sine x, so I can take my 12 outside the integration, that I have 12 multiplied by the integral of sine x dx. So I continue. So I can now find the integral of this x and find the integral of sine x. So there I continue. So integral of x, this x has power 1, in which that 1 will increase by 1 to become 2 power 2. So I'm going to have x raised to 2 all over 2. This is the integration of x. Remember, the power after increasing it, it will now be used in the division. That is, that the power after increasing it will now be here, minus, then I'm going to have 12 times the integral of sine x, which is minus cos x, then plus the constant of the integration. So I continue. So I can now do this multiplication, that is minus 12 times minus cos x. There it gives me x squared over 2 plus, that is, this plus is minus times minus, that changes to plus. Then you have 12 cos x plus c. this will now be the integral of this function x minus 12 sine x dx. Let's take another example. Example number 2, you asked to find the integral of cos x minus 2 sine x dx. Solution to this very problem, copying down the given text, that is the given function that I wanted to find, it is integral. Integral cos x minus 2 sine x dx. Here also I have two terms, so I can apply that very property of integration and find the integral term by term. So I'm going to have integral cos x dx minus integral 2 sine x dx. I continue. So there I will now have my cos x, which I just copied here, and this is 2 times sine x. I will apply the other property of integration, which says if you have a real number multiplying this, you can now take this to 2 outside the integral. You now have 2 multiplied by the integral of sine x dx. I'll continue. So I'll now find the integral of cos x and also find the integral of sine x. That is what I'm going to do next. So integral of cos x, that will be, remember, is sine x minus the 2 times integral of sine x. Remember, integral of sine x is minus cos x. So you are going to have 2 times minus cos x, then plus the constant of integration. I keep repeating, don't forget this plus c all the time. So we continue. I can now do this multiplication. That is minus 2 times minus cos x. That will now give positive to 2 cos x. So I'm going to have sine x plus 2 cos x plus c. And this will now be the integral of this very function, cos x minus 2 sine x with respect to x. Example number 3, you asked to find the integral of 8x raised to 3 plus x squared x dx. Solution to this very problem. What to do, I'll copy the given text. That is integral of 8x raised to 3 plus x squared x dx. Here also, if I check, I can see 2 terms here. So applying property which says integral term by term. If you have the function that has more than 2 terms, more than 1 terms, I beg your pardon. So this will now be integral of 8x raised to the power of 3 dx plus the integral of x squared x dx. So you now find this integral. So I'll continue. But this is 8 times x raised to 3. And there I can now say that this will now be equals to 8x raised to the power of 4. This power 3 increased by 1, so you have now power 4. And you divide that very term by the power after increasing by 1. So there I have 8x raised to the power of 4 plus 1. I'll continue. So I'll now find the integral of this x squared x. The integral x squared x, remember, it says integral of x squared is that x, then plus the constant of the integration. So I'll now simplify this very first term. I can divide 8 by 4. There I'm going to have 2, then x raised to the power of 4, then plus that x plus c. This is now the integral of this very function, 8x raised to the power of 3 plus x squared x dx. With these few examples, I hope you'll be able to find the integral of a trig function. So this is where I'm going to stop in this very lesson, my dear student. And let me just move to the last segment. Maths is fun, and explain the second relationship between those two favorite sequence of numbers, that is Lucas and Fibonacci sequence of numbers. This relationship says for every even index Fibonacci number. That is Fibonacci number at a position, and that position is an even number. The number you obtain at that even index position in your Fibonacci will now be a product of one Lucas and one Fibonacci number. Let's just take this to our favorite sequence. This is the Lucas and this is the Fibonacci sequence. So if I take this 3 in my Fibonacci, that occupies position 4, and the 4 is even. So this 3 is simply the same thing as this Fibonacci 1 multiplied by this Lucas 3. So multiplication of 3 and 1 gives you this 3. Let me take another number, like I've said, 8. 8 is in position 6 and 6 is even. So 8 is nothing but 4 multiplied by 2. And you can see 4 is a term in the Lucas, while 2 is the term in the Fibonacci. So any term you take in your Fibonacci, that term is, if it is in position, a particular position that is even, then that number will now be a product of two numbers, and those two numbers, one will come from your Fibonacci, the other one will now come from your Lucas sequence. Let me just take one more. I take 21. 21 is in position 8, and 8 is even. So this 21 is the same thing as 7, one of the Lucas term, multiplied by 31 of the Fibonacci term. It gives me this term at position 8. So I believe for those that are familiar with these two sequence of numbers, never noticed this relationship between the two sequences. Thank you for your attention. We see more of this aspect of it in our subsequent lesson.